So quantitative analysis in budgeting has got two components. There is the high-low method and the learning effect. So start with the high-low method. At some point in our study, we'll be looking at preparation of budgets. In order to prepare budgets, we'll have to forecast some of the costs and revenues which are incorporated in the budget. Okay. So one method which we use is known as the high-low method, and the other one is the linear regression method. This analyzes costs into fixed and variable elements. So the high-low method, we use it to split total costs into the variable component and the fixed component. Okay. So we have this question. Now, to use the high-low method, you pick the high from the unit side. You don't use the money side to determine the high. Okay? Although you may find that in most questions, the high money will relate to the high units. But some questions not be like that. So if you use the money side, you end up getting from. You pick the high from the unit side, you pick the low also from the unit side. Then you subtract the high units. Now when you pick the high units, you marry them to the corresponding cost.
Labor cost.
In this case, labor cost, yes. It could be any cost that you are given. You may be given total costs. So
from labor you don't choose high-low. As in from cost you don't choose, only from units. Yes. From units what you have chosen, the corresponding you also choose, even if they are not high-low.
Correct.
Yes.
Correct, yes. But as long as the high is coming from the units.
Right.
Yes. So then you subtract. In this case, the 14, that's what we've chosen. In the 10, subtract the 14 and the 10 to give you 4,000. Then the corresponding 35, you subtract the corresponding 27 to give you 8,000. The 8,000, you divide into the 4,000. Remember, when dividing, the money is always on top. So 8,000 divided by 4,000, that will give you your variable cost per unit, which is 2. Then you choose either the high or the low.
Okay.
You choose one of them.
Cost or units?
No, because when you choose the high, it means you're choosing everything in the high.
Okay.
Yes. Or the low. Doesn't matter which one you choose, the answer will be the same. So in this case, we've chosen the high. So we take the total costs of 35. So your formula, to take down the formula is y equals a plus bx. Y equals a plus bx, where y equals total cost A equals fixed costs B equals variable costs per unit X equals output. So we substitute in this formula. Our variable costs, we have 2. So it's going to be 35,000 equals A plus 2 times the output for 35,000, which is 14,000 units. So 2 times 14, which gives 28,000. So you change to make A the subject to the formula, so you get your fixed cost as 7,000. So that's how we use the high-low method. Okay? You need to memorize this formula I've given you. It's called the total cost function formula.
Total cost equals to fixed cost plus variable cost. Plus variable cost times output.
Yeah. So this formula assumes that fixed costs remain unchanged in the short run, and variable costs per unit are constant. Okay? However, in reality, this may not be the case. We'll see as we move some questions where the variable costs or the fixed costs may be constant up to a certain point and then increase, like the stepped cost we looked at under in F2. Okay? But for now, we assume that the fixed costs remain unchanged and the variable cost per unit are constant. So we're done with high-low method. We move to the learning curve theory. This theory is that when new work practices or products are introduced, the theory is that a workforce gains experience in a particular task. As they gain experience, there will come a point when they will start performing that task much quicker, because they are now familiar with the task, they've learned how to do it. So the labor costs and the variable costs, that is assuming they are labor driven, will be lower in later periods than at the beginning when they started making the product. Okay. This will eventually lead into the variable costs, the variable labor cost to the product becoming low, hence reducing your total labor cost. But for the theory to hold, a number of conditions must be applicable. The first one is that there is a significant manual element in the task. Okay? The task is not so automated. Most of the procedures are manual. Okay? The tasks are also repetitive. Since they are repetitive, then they'll be doing the same things over and over. The workforce will become much more conversant with the task. Okay? The third one is that production must be at an early stage so that there is room for improvement. Okay? They've just started producing in the early stages, so that as time goes by, they're able to improve in their production methods. The fourth one is that there must be consistency in the workforce. You are not changing your workforce over and over, because each time you bring a new employee, it means they will go back to the beginning and start learning afresh. The fifth one is that there must not be extensive breaks in production, or workers will forget their skills. Okay? If they take a very long break, when they come back again, they start learning afresh. And lastly, the workforce must be motivated. The rule, which is very critical as we apply the calculation, the rule is that as cumulative output doubles, okay? Cumulative output doubles. The cumulative average time per unit falls to a given percentage of the previous cumulative time per unit. Clear?
Repeat it.
As cumulative output doubles.
Cumulative, what does it mean?
Cumulative is if you produced 2, then you produced another 2, so cumulative you got 4. Okay. So as cumulative output doubles, the cumulative average time per unit falls to a given percentage of the previous cumulative time per unit. Okay. The cumulative average time is the average time of all units produced so far. Clear? So the time taken will continue reducing until it reaches what is known as the steady state. The steady state is the point at which there is no more learning. So the steady state is where you now set your standard. Okay, this is the time that we expect everybody to take to produce this product. Okay, so the steady state, at this point, there is no more learning. Then you set your standard from the steady state. We'll quickly look at an example.